This process is helped by accessory muscles. During expiration, accessory muscles such as the anterolateral abdominal and the innermost intercostal and internal intercostal muscles help to dramatically increase the pressure in the lungs and decrease the volume, so air will be forcefully exhaled. However, again, during forceful inspiration, accessory muscles are also used, such as the external intercostal muscles, contracted by accessory muscles such as the scalene muscles and sternomastoids, helps to raise the ribs up and the sternum. The serratus anterior to elevate the ribs, the latissimus dorsi to lift the lower ribs, and the pectoralis major to contract, causing the ribs to move outwards to decrease the pressure as much as possible and as quickly as possible. The diaphragm during active inspiration flattens as usual. This causes the pressure inside the lungs to dramatically decrease, and therefore, from Boyle's law, the volume also rapidly increases. This causes a steep gradient of pressure in the external environment and internal environment, and air always moves from high to low, so air is sucked in very quickly. Therefore, with each breath, there is a higher volume of air being sucked in, and a higher volume of air being exhaled. Therefore, more oxygen can be supplied to the working muscles, and more carbon dioxide can be expelled more quickly with active inspiration and expiration. The ventilation will therefore increase dramatically from at rest. The breathing rate overall changes from 13 breaths at rest to 46 breaths per minute at post-exercise in the multi-stage fitness test. At 46 breaths per minute, with a tidal volume of 3,500 milliliters, the ventilation is around 160 liters. There are many times throughout a hockey game when the ventilation will change, and this is due to what happens on the pitch. For example, a striker in hockey may have a lower breathing rate when the ball is on the other side of the pitch, as they are less actively involved in the game, and therefore do not have to work as hard, and less muscles are contracting, so less breath will be sufficient in supplying the muscles with the oxygen it needs, whilst also expelling the waste products. At this point in the game, the striker will be breathing without forced inspiration and expiration, without accessory muscles, because it is not necessary to do so. However, once the ball comes closer to the striker and a through ball has been played, the striker may have to sprint and work very hard to get to the ball, and once the play is broken down or a goal has been scored, the ventilation of the player will have increased much more. This is because there has been an increase in movement, body temperature, and levels of oxygen and carbon dioxide and lactate in the blood. The receptors, proprioceptors, thermoreceptors, and chemoreceptors, will have detected these changes and sent feedback to the respiratory control center to increase the rate of breathing. Accessory muscles would also be contracting to increase the pressure or decrease the pressure in the lungs more dramatically, to force more air in and out of the lungs more quickly. Therefore, ventilation will increase and a higher volume of air will be inhaled into the lungs, and a higher volume of oxygen will be diffused into the bloodstream from the alveoli, and there will be a higher pressure of carbon dioxide in the blood, and this will diffuse across into the alveoli to be exhaled. The breath will remain high until the intensity of the work slows, and the resting breathing rate may take a couple of minutes to happen again, as the body is flushing out carbon dioxide and still supplying oxygen.